Hey everyone, welcome to the 5.5 notes. Today we are going to learn how to graph radical functions. The front side of the worksheet is all going to be square roots, the back side is all going to be cube roots. Before we get started, just a couple of reminders about transformations. If there is a number in front being multiplied like this, that is when you're going to multiply the y values by whatever a is. And this is either going to make a stretch, a shrink, or a stretch, shrink, and reflection. So remember that a reflection is when it sort of like flips. If there is a number on the inside being added or subtracted, if it is being added, it is going to go to the left. If it is being subtracted, it is going to go to the right. So this is the part where it's a little backwards from what you might think, because things inside work backwards. So kind of rework your brain for a second, or always tell yourself that this is always going to be the opposite. And then if there is a number outside at the end, this should make sense. It's going to go up and down. Up if it's a plus, down if it's a minus. So here's why that's important. We are going to graph the square root function over here first, and then we're going to move it. So for example, since this is a plus on the inside left if it's a plus, so this goes left 3, and there's a minus on the outside, so that's going to be down 5. And what we're going to be moving left 3 and down 5 is the original f of x equals the square root of x function. So whatever this is over here, all we have to do is move all of the points left 3 down 5. And what I'm going to do is draw a table. I don't necessarily recommend doing this every single time because it would be a little lengthy. I'm going to take values for x and plug them in, like 0, 1, 4, and 9. Now, where am I getting those numbers from? These are all numbers that are easy to take the square root of. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So to get from this number to this number, I am doing the square root. And then I'm going to go put these points on there. 0, 0, 1, 1, 4, 2, 9, 3. Boom. And then we're going to connect them. Now, one thing very specific about this graph, it starts here at 0, 0. I'm not allowed to take the square root of a negative, so there is absolutely nothing on this part of the graph. It only goes to the right. Some people call this the eyebrow shape. Some people call it the yawn and stretch shape. Okay, and then all I have to do over here is I'm going to move left 3 down 5, and I'm going to start with this first point. So I'm going to go left 3 down 5. And then from there, I'm just going to follow this pattern. From the middle point, I'm going up 1, right 1. And then I'm going up 2, right 4. And then I'm going up 3, right 9. So from this middle point, I'm going to go up 1, right 1, back to the middle point, up 2, right 4, back to the middle point, up 3, right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another way of doing this is to draw this over here and then move each point right 3 down 5, left 3 down 5, sorry. So it's the same shape in both graphs, but this one's just been moved left 3 down 5. And then on the right, this is going to be a stretch by 2. So we are going to multiply with the y values by 2. And there's a plus on the inside. This plus on the inside was left, so this is going to be left 2, but at this time it's left 4 instead. I should have said left as well. I didn't mean the number 2. And then we're going to graph it. Okay, so the first thing I'm going to do is I'm going to move left 4. So instead of my middle point being here, now it's going to be here. And then for this pattern, I'm going to double all of the ups. That's what it means to multiply the y's by 2. So I'm going to go up 2, right 1. Then I'm going to go up 4, right 4. And then I'm going to go up 6, right 9. So where am I getting these numbers from? This, but I've multiplied these by 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. But my x values, or the right part, didn't change. This part's still the same. Only multiply the y's. These are the x's. So up 2, right 1, back to the middle. Up 4, right 4, back to the middle. Up 6, right 9. And there you go. So see how when there's a whole number in front, this gets really big. So it's a bigger eyebrow or yawn and stretch than the other two. Now, there is domain and range listed here that we're going to go fill in. Just a little reminder that domain is the x's, and those go left to right. So all you need to ask yourself is, how far to the left can my graph go? This graph stops going to the left right here at 0. That's the x value right there. But to the right, it never stops, so that's infinity. And then these are all closed circles. We will only have closed circles. So this is a bracket. The only thing that will never get a bracket is the infinity. And then I'm going to go ahead and do all of the domains first. So the furthest to the left this graph goes is right here at, looks like -3. But then it goes to the right forever as well. And then the same thing, this was a closed circle, so it gets a bracket. Infinities always get parentheses. And over here, my graph goes to the left to -4. And then it goes to the right to infinity. Bracket around the whole number, parentheses around the infinity. There will be no open circles. We don't normally do those with a graph. There's a very specific type of graph those go with that you will learn in college algebra, but not in algebra 2. So these will always be brackets with the whole number part. The range is the same idea except for with the y's instead. And instead of looking left to right, since we're dealing with y values, that's bottom to top or down to up. So the lowest point on this graph is right here. Again, it's at 0. And then even though it's hard to tell, this graph is actually still going up. It might be going up very slowly, but it's still going up to infinity. And then the same thing happens with the bracket and parentheses. But this graph has been moved down. So now the lowest point is right here at -5. And it also goes up to infinity. And then the range over here, the lowest point is right here at 0. And it always goes up to infinity. Or these do at least. Does not always go up to infinity. Okay, when you were dealing with a range, remember that you're using these values. So like even though this is at -4, this value on this number line, the y number line or the y-axis is 0. So even though this one was at -4, the y part was at -5. So make sure you're looking at the right axis. Okay, and then we have 2 on the bottom. This one is actually going to be a reflection. That happens whenever there's a negative in front. This 4 is on the outside. See how the square root ends right here? That means it'll go down 4. And I'm actually going to do the down 4 first. Always start with the left, right, up, down part. I'll zoom in just a little bit. So it starts in the middle. Now we're going to go down 1, 2, 3, 4. And then instead of going up 1, right 1, since I'm multiplying by a negative, this is going to be my new pattern. So I've taken this pattern from up here, and I've just changed the ups to downs because now they're negative. So when I go up -1, I'm really going down 1. So I'm going to go down 1, right 1. Next point. Go back to the middle, go down 2, right 4. If you're looking for a way to remember these, by the way, this number squared is this number. And then down 3, right 9. And then draw an upside down eyebrow or yawn and stretch this time. And then we're going to go look at the domain. Left to right, the furthest to the left this graph goes is here. The x value, this one, is actually here in the middle at 0. And then it still goes to infinity on the right. Even though this graph is going down, these values are going up. And then the range is bottom to top. Well, the bottom of this graph is negative infinity because it keeps going down forever. The top of this graph is right here at -4. So since this one is upside down, the range is sort of flip-flopped. And then we have one more square root before we move on to the cube roots. We are going to multiply the y's by -3. And then we are going to move right 2 and up 4. Alright, so I'm actually going to do this in 2 pieces. I'm just going to let you know this now. I'm going to go right 2 up 4 first. And I'm actually going to draw the original graph, and then I'll show you why this isn't always the easiest option. So this is just me copying down the points from up above. You do not have to do this part with me. In fact, it may be easiest just to wait a second. This is the original function. And then I'm going to move everything right 2 up 4. Right 2 up 4. Right 2 up 4. Right 2 goes slightly off my graph, but I'm still going to use it, up 4. Like that. Then I'm going to multiply the y values by -3. But if I do it from this point, I'm not just going to multiply them straight up. I'm going to multiply the distance between them. So this distance right now is 1. I want it to be 3, or -3. So instead of going up 1, I'm going to go down 3. And I'm keeping the middle point. So really what we're changing is this part right here. We're multiplying that difference by -3. So then this difference was 2. 2 times -3 is -6. So instead of going at 2, I'm going to go from here, which is even with my point, down 1, 2, 3, 4, 5, 6. So that now this is 6. And I would not draw those little marks on yours. I'm just trying to show you. And then this one here was 3. 3 times -3 is -9. So now I need to make sure that this is -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And over to where that point already was, which was 1 off the graph, not a really big deal. It's 1 or 2 off your graph, you're fine. And that's my graph. the highest point on my graph, or sorry, the furthest to the left, let's do domain first, is right here, which is at 2. And then it goes to the right to infinity, which makes sense because we moved it to the right too. And you take the original domain and you move this to the right too, that's what it's going to be. So you can almost do this part just by using the x part of the transformations. And then the y part of the transformations moved up 4, so the 0 is going to become 4, but then it went upside down. So instead of 4 to infinity, it's going to be negative infinity to 4. This bottom always goes first, and it's going down to negative infinity, but it stops going up at 4. And then we're going to talk about cube roots for just a second. I'll give everybody a minute. Don't make any of my little markings. Those were just visuals. And we're going to flip to the back side for the cube roots. I'm only going to list x values that I know I can take the cube root of. That would help. There we go. I'm looking at the wrong graph. Okay, so whatever numbers are going to go over here, to get our y values, we're going to take the cube root of them. So I can take the cube root of 0, 1, and 8. And then the next number that I can take the cube root of, the next perfect cube, is 27, except for one other thing about cube roots. You're allowed to include negatives now. So I'm actually going to include -1 and -8 as well. So I have 0, the cube root of 0 is 0. And then the cube root of 1 is 1. And I'm going to skip down here. The cube root of -1 is -1. So if there's a negative, when you do the cube root, it just stays negative. The cube root of 8 is 2. So the cube root of -8 is -2. And then I'm going to go put all of these points on my graph. 0, 0, 1, 1, 8, 2. -1, -1, -8, -2. And think of this as like your parent function. Here's why I don't want you guys to do the table every single time. You're going to get real tired of doing that real fast. We are still going to use 0, 0 as our center or our focus point. And we are going up 1, right 1. And then we are going up 2, right 8. But we are also going down 1, right 1, or left 1. I'm going to do it capital L, let's do that. And then we're going down 2, left 8. So we're doing the same thing, the same pattern twice. I'm going to help show you what that means over here. Because I think once you see an example, you're going to be like, oh, it's actually not that crazy of a thing. Before I move on to the second example, though, the domain and range for all of these, it's going left and right forever. Because we didn't have to cut off the negatives like we did with the square root. So it's negative infinity to infinity. And because we didn't have to cut it off, it's also going up and down forever. Even though it looks like it's pretty flat, it is still going up and down, just very, very slowly. And then I'm going to take this whole graph for the second example, and I'm going to move it left 5 and down 2. Here's how the easiest way to do that is. Start with your middle point, left 5, down 2. And then follow your pattern on each side. I think of this kind of like a seesaw. You're going to go up 1, right 1, up 2, right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you're going to go from that middle point again. So don't lose track of where your middle point is. Down 1, left 1. Down 2, left 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to leave it there only for a frame of reference. Some of those extra points are going to go off the graph with these because they're such big functions. And then you're going to draw your little, I call it like the seesaw. Okay. And again, you can't change the domain and range for these guys. The cube root is going to be negative infinity to infinity on everything. That's never going to change unless it's not a cube root anymore. So it's really only the square root you have to focus on. And then on the bottom here, I'm going to move right 3. And then I'm multiplying my y's times 1/2. So what that means is my pattern is going to be and I'm going to show you where I'm getting this from, so don't freak out on me. I'll give you a chance to write it in just a second. So the right 1, right 8, left 1, left 8. Same. But then I multiplied the ups and the downs, the y parts, by 1/2. 1 times 1/2 is 1/2. 2 times 1/2 is 1. 1 times 1/2 is 1/2. 2 times 1/2 is 1. So what I'm going to do is go to the right 3 from my middle point, 3, and then I'm going to go up 1/2, right 1. I'm going to go back to the middle point, up 1 over 8, which puts me 1 off the graph. And then down 1/2, left 1, down 1, left 8, down 1, left 2, 5, 6, 7, 8. And it's going to make this really skinny one, like that. And then I'm going to go ahead and do this one, and then I'll draw my domain and ranges for you guys. So this is going to go right 7, up 1, and because this is a negative, you're going to multiply your y's by -1. So my new pattern is going to be down 1, right 1, down 2, right 8, up 1, left 1, up 2, left 8. So the ups and downs are just flip-flopping. Start in the middle, go right 7, up 1, down 1, right 1, and then down 2, right 8 is very clearly not going to fit, but I do know that it's going to be somewhere out here, so I'm just going to guess. And then up 1, left 1, from the middle, up 2, left 8, and here you have it. So see how it's going sort of like this instead of the normal, it's almost like they just flip-flopped. It's going the other direction. And then at the end, both of your domains and ranges are going to be -infinity to infinity.